So there are three common types of mirrors. First is the plane mirror, next is the concave mirror, then the convex mirror. And there are some basic terminologies that you need to know while studying spherical mirrors, and here are some that I have accumulated. First is reflection, or the bouncing of light rays when it hits a surface like mirrors. Next is regular specular reflection. It is where the angle of incidence is equal to the angle of reflection. Specular reflection is the reflection of smooth surfaces. Keep in mind that all plain, shiny surfaces exhibit this kind of reflection. Are you getting me? If you have any question, please feel free to ask in the chat box and I will read them. If none, I will continue talking now. Okay, next is irregular or diffuse reflection. I am so sorry for the background noise. This is the hardship of the new normal. Irregular or diffuse reflection, the reflection of rough surfaces illuminate shaded areas such as under the trees and inside the buildings. Okay, next, law of reflection. State that the angle of incidence or angle of incident ray is equal to the angle of reflection. The angle of incident ray is measured between the normal line and the incident ray, while the angle of reflection is measured between the normal line and the reflected ray. If you want to screenshot this, it's okay. So bear in mind that the result of the reflected image can be characterized according to image orientation, location, size, and magnification. So first is image, or it can be real or virtual. Orientation, it can be upright or inverted. Location depends on the object location. And size and magnification, size can be smaller, larger, or same with the magnification of more than 1 if it's larger, and less than 1 if it's smaller, and equal to 1 if it's the same. Did everyone get that? More than 1 if it's larger, less than 1 if it's smaller, and equal to 1 if it's the same. I am advising you to screenshot this so you can look back into it. So plane mirror is the plane flat reflecting surfaces that we frequently use in combing our hair and etc. So imagine blasting a beam of parallel light in a mirror. What do you think will happen? If you're thinking that it will reflect the same parallel beam of light, then you're correct. You're indeed correct. But what type of reflected image will it form? What do you think? So I have here a picture, and I need you to imagine yourself looking at the bee above you in front of the mirror. The type of image that it will form is virtual, while the image orientation is upright and laterally inverted. What is laterally inverted, ma'am? Laterally inverted is caused by a phenomenon called lateral inversion, which is the right side of the object appears to be on the right side of the reflected image and vice versa. Okay, so next is spherical mirrors. A mirror which has the shape of a piece cut out of a spherical surface. There are two types of spherical mirrors, concave and convex. So, now for our little observation or experiment. can I ask everyone to get a spoon, a metal spoon to be exact, and try to look at your image at the both sides of the spoon. And tell me what do you observe. It's okay, the chat box is open for your answer. So the reflected image that we just observed is the image that we can produce in a curved mirror. Note that the curved mirror is reflecting surface that comes from the section of a whole sphere. There are two types of curved mirror that we will discuss, which is the concave and the convex mirrors. The inward part of the spoon is the concave and the outward part of the spoon is the convex. Okay, so concave mirrors. These are the spherical mirrors that is curved inward, and the images obtained from these mirrors depend on the location or the placement of the object. Now let's see what will happen if we blast a parallel beam of light in a concave mirror. The concave mirror converges the light rays to a single point. That's why concave mirrors are converging mirrors. Okay, now I am showing you a picture where there is principal axis, center of curvature, vertex, and focal point. Because we need to talk about the type of reflected image we can form in a concave mirror. But before that, we have to define some terms. So principal axis is the imaginary line that passes through the center of curvature and the pole. So the center of curvature is the center of the hollow sphere of a glass which the mirror is apart. Vertex is the center of the surface of the concave mirror. The focal point is the midway between the vertex and the center of curvature. Did everyone get that? Can everyone follow? Okay, so I will continue now. Okay, so I have here list of pictures and examples that I will give you to better understand what concave mirror is. So example number 1, as you can see in the picture, you can screenshot it because I will go on to the next slide. Example number 1, if the object beyond the center of the curvature, the location of the reflected image will always be at the middle of C and F. What is C and F? C is the center of curvature and F is the focal point. Its orientation is inverted. The size of the reflected image is smaller than the actual object. So, if the object is 5 meters high, its reflected image will be less than 5 meters high. The absolute magnification of the image is less than 1. It's considered as real image. Okay, so for the next example, this is the picture and going to the next slide. Example number 2. If the object is located at the center of the curvature, the image will also be located at the center of the curvature. Its orientation is still inverted, but the size and the magnification of the reflected image is equal to the object, and the image produced is a real image. Okay, so I'm going to the next slide. This is the picture for the example number 3. Okay, example number 3. Regardless of the location of the object between the center of curvature and the focal point of the reflected image will always be located somewhere beyond the center of curvature. In this case, the image will be inverted, but the size of the reflected image is larger than the object, and its absolute magnification is greater than 1. The image will also form a real image. So I hope everyone understand that, because I am going to move on now to the convex mirror. Okay, so class, I have here a picture that says placement of the object and image obtained. Because as I have said earlier, the image that you'll obtain will always be based on the placement of the object. So if it is placed at the infinity or placed at infinity, it will be highly diminished, real, and inverted. If it is placed beyond the center of curvature, the image obtained will be diminished, real, and inverted. If it is placed at the center of curvature, it will be the same size of the object, real, and inverted. If it is placed between the center of curvature and principal focus, it will be enlarged, real, and inverted. If it is placed at the principal focus, it will be highly enlarged, real, and inverted. If it is placed between the principal focus and the pole, the image obtained is behind the mirror, is highly enlarged, virtual, and erect. Okay, next is convex mirrors. These are the spherical mirrors that is curved outward. A curved mirror where the reflective surface bulges towards. Now, just like what happens to the other two mirrors, let's imagine blasting a beam of parallel light into a convex and see what takes place. Unlike the others, convex mirrors diverge the light rays. That's why it is also called diverging mirrors. Now let's find out what reflected image it can produce. In convex mirror, the location of the object does not affect the characteristics of the reflected image that will be formed. Convex image will always produce a virtual, upright, and smaller image that is located at the opposite side of the mirror. So these are some key points that you need to remember in the convex mirror, or if we talk about convex mirror. So the image formed in the convex mirror is always virtual and erect, whatever the position of the object, unlike the concave mirror where the position of the object is very important. When the object is placed at the infinity, a virtual image is formed at the focus. The size of the image is much smaller than compared to that of the object. When an object is placed at a finite distance from the mirror, a virtual image is formed between the pole and the focus of the convex mirror. The size of the image is smaller that of the object. Okay, so class, any idea where you can apply or where you can see convex and concave mirror in real life, and what are some important uses of this? You can comment it down at the chat box. Okay, so here are some examples that I have gathered. In convex mirror, it is used for security purposes in stores because they broaden the reflected field of vision, allowing clerks to see a large sections of the store. The images are smaller than the objects, but the mirrors help to see a wide area. Next, in the concave mirrors, dentists use concave mirror to see enlarged images of the teeth for examining it. If an object is placed close to a concave mirror, it forms erect and enlarged images or image of the object so that the dentist hold the mirror in such a way that the tooth lies within its focus. Have you ever been in a dentist class? Have you seen this kind of tool that the dentist used to examine your teeth? Okay, so that's the end of our discussion. And thank you all for participating today. You deserve a good rest. See you in the next meeting.